All right, welcome back. So in this particular video, we're going to continue working on our schematic for the Fusion 360 electronics version of the light sensor. And so in this particular video, we're going to hook up this connector that allows us to interact with the microcontroller. So you might be asking, well, how do you, it's a chicken or egg scenario. You've got this microcontroller that doesn't know how to talk. You have a UART link, and so without some mechanism to talk to that that microcontroller, to download code to it, you might be saying, well, how do you even make this thing work? Well, you could use the bootloader that's inside the STM32 and just use a serial port. That is certainly an option in a production environment. Maybe you do that, but in a development board like this, where we really want to do software development with this, as we're trying to get the application sorted out, we really need more than that. We need the ability to do things like set breaks, use an advanced IDE, things like that. You really need other mechanisms. You might want trace to see kind of, why is it blowing up right after this interrupt gets fired, that sort of thing. You might need to have the ability to trace instructions in and out of different things. And so things like software debug connectors are great for that. And so I wanted to show you kind of, where we're going with this. So if you look at our here's our debug connector, this little 14-pin connector. It actually turns out to be a connector from a company called Samtech down in Louisville. They make this little connector that hooks to a pod here that, again, ST makes this pod. There are lots of debugger manufacturers out there, that make different types of pods, J-Link being kind of the most ubiquitous one. This one is it's about a $35 device. This is called an ST-Link version 3. And it's got this little connector here. This is the female side of the connector that will plug into, this little JTAG connector, or this little software debug connector like this, right? So you're going to plug it in, and that lets you do things like use your debugger and set breakpoints and watch points and trace and do all that sort of really helpful stuff that, that is kind of the predicate for all modern embedded software development. You really just have to have those sorts of tools. So if I zoom in here, I'm going to connect this up largely to pins that I've already hooked up. Let's go ahead and hook up power and ground to it. And so I'm going to go ahead and grab this guy here. And I'll right click in, copy him. I don't know why I'm having trouble getting hold of that VCC. And so this connector does things like, say you would like to get on to design, make sure this is on nets, do this, make sure that we're doing continuous. And so this TVCC is, it'll measure the target VCC and make sure that it's up. Of course, it takes ground for reference. So we'll put a ground pin down here and we'll connect it up. We'll hook ground detects and make sure that it's got a ground on it. This RX will be the RX from above, where we hook that up to the low power UART. And so let's go ahead and name this RX. Give me a little warning, yes, that's okay. And then let's go ahead and do TX. And in fact, as you become more comfortable with it, when you're connecting these up to nets that already exist, it's kind of a good check to make sure that indeed you are getting that error message, which means it is hooking it up. I don't know why it decides to lay that label on top of that dialog on top of that. All right, so we want to hook up in reset, which is right here in RST. So let's go ahead and hook it up to, and we'll name it. Okay. Yes, I want you to be over here. Maybe you won't pop up there anymore. All right, some of these pins, like I said, these JTAG pins, are not going to be used in our design here. So we are going to hook SWO up here. So these are our software debug pins. And so we'll name that SWO. Yes, that's good news. Let's go ahead and hook up this. We'll name that SWCLK. Yes. And then we'll hook up this guy, SWDIO. Okay. Okay, so let me go back over and just make a quick check here to make sure that indeed I have what's connected. Yep, that looks good. All right, okay. All right, so let's go ahead and draw. I'm gonna go ahead and move this around here. So I'll select it, and then I'll move it, and I'll move the group. I got that corner on accident here. Go ahead. Oh, now I goofed it up. Delete that. And so let's go over to document and line, and we'll put that on info. I got to repair my mistake. Oh. Let's go ahead and make the short dash. All right. And let's see, we'll go ahead and do this down here. We'll make a box around this. And we'll call this, debug. Oh, it kind of disappears. If you debug, and then you've got to place it before you can be done. All right, so there we go. All right, so we're almost there. So we've got everything short of light sensor itself. So we need to add the light sensor. So I'm going to go ahead and add that. It is a TSL237, and so I'll go ahead and grab that here. All right, so it's got a ground and an output and a VDD. Now, with this particular sensor, one thing that we're going to do is we're not going to hook it to VCC because we don't want it to run all the time because it would draw, you know, a few milliwatts all the time if it were on. And so with a light sensor that takes data once an hour, we don't want to burn those milliwatts of power while, you know, we're not even looking at the data. And so in this particular case, what we're going to do is we're going to hook it to a GPIO pin. And so if you remember over here, I may have gone over it really quick. I called this pin TSL237 enable, EN. I'm going to turn that to I'm going to make that my power pin here. Design, get back on the net layer, select that, make sure this is continuous. And so I'm going to move this to, I'm going to call this named TSL237 EN. Okay. And I'm going to go ahead and hook this one to ground here. So I'll go ahead and copy this ground. And then I'm going to hook this one to this pin right here, TSL237N. And so I will name that TSL237N. All right, so let's go ahead and put a decoupling capacitor to. Again, decoupling capacitors are just generally helpful in a lot of different scenarios. I'm going to go ahead and copy this. And you may get functionality. The problem with the decoupling caps is the thing may pretty much work, But when you really start to look at the data, you might see, oh, wait a second, this thing's not nearly as stable as I thought it was. All right, I'm getting some weird behavior, so I'm going to go ahead and move this group here down. And we'll go ahead and copy this here. And then we'll go ahead and wire it. All right. So now we'll go ahead and draw a box around it. Document, line, info, short dash. I'll make a box around it. I'll give it a name here. I'm going to call it sensor. Okay. There we go. So there's our schematic. I'll go ahead and zoom in. All right, so we're on our way here. We've got a pretty good running start on a working schematic here. So let's leave it here for this time, and then we will come back and we'll look at the electrical rules check to make sure that everything's hooked up. We don't have hanging nets that we don't expect. And then we will we'll go on to, I'll show you how to start the layout. All right, more next time. Again, we'll do the electrical rules check, and then we'll go ahead and look at what the initial layout looks like, and then we'll really start looking at how do we lay this thing out.